off a little project that I was working on. So I don't usually get to work on MicroPython projects. Well, yeah, not lately anyway. I just work on MicroPython to make it, work well. But I think it's good to try and use MicroPython every now and then to give feedback to myself of what's good and what's not good and everything. So I was playing around. I got a big EPaper display off AliExpress, and I was playing around with it. And EPaper displays are really cool when you get to get them working. And I wanted to make just a simple weather display, and here you can see it's sort of work in progress, but this is what it looks like at the moment. So this is like a where is the centering there? It's very reflective. This is 800 by 480 pixel, 7.5-inch display. Yeah, it's really good. So it's just got this adapter dongle here, and then there's a Pi board running connected to it, and it can have a battery eventually. So the aim is to just show the weather, but the idea is to show the BOM weather, Bureau of Meteorology here in Australia, because that's far better data than any of the other open weather APIs, at least what I find for where we are. And so this is actually correct for the current time, and I'll show you it updating. It won't update anything about the weather because the weather's not going to change since like 2 minutes ago. But you can see it takes about 1 second to refresh. So it flicks back and forth. So I can run it again. So you can see the time change from 1916 to 1918. But it won't actually, yeah. So it's pretty quick to update, actually. It has this fast update mode, which hopefully doesn't break it if you use it again and again, but it should be fine. So yeah, it's about 1 second to update. It's just a SPI bus, and I'm just using a frame buffer. It's like a 48K byte frame buffer, mono. But yeah, a lot of things. There's a lot of components here. I won't talk about them all in detail, but it was a lot harder than I thought it would be to get something like this working. This is actually inspired by another project that I saw where it used the ESP32 and it was written in C, and I thought it'd be fun to rewrite it in Python, in MicroPython. But there are the things that are much more involved than I thought, are like getting icons for weather, getting fonts. The size of fonts and icons is it's like a megabyte of assets here for the fonts and the icons, because they have to be stored. They can't be compressed. They need to be stored in a way it can be rendered. And then when you download from the BOM, it has like an API, but it's really not well documented. You have to go log into an FTP site and there's like thousands of files, and you have to find the one relevant to your location and download that. And then you find that the XML file that you download is very large, and you have to parse it and find the relevant, information in it. There's a lot of stuff that you don't need. So even just loading it into memory on a microcontroller is tricky. But that just gives you forecast. To get current observation, like what the current temperature is, you have to go and download a different JSON file, and you have to know where that JSON file is. And that's not on the FTP server. That's like just some API HTTP endpoint. And then that JSON file turns out to be hundreds of kilobytes large, and you can't load it all into memory. And because it contains observations for like the past 72 hours of like every minute or something, or every 10 minutes. And so you have to have like a streaming JSON parser to parse the JSON file. So there's lots of complicated things that I ran into, and it's quite fun to solve these things. So I will talk about these hopefully next time when I've actually finished the project, or at least got it a bit more working. But it was really fun so far. The EPaper displays are really cool. It was only like $50 from AliExpress, which I thought was pretty reasonable. So you can get color ones as well, and even bigger ones. And they're pretty usable. The driver though I had to write from scratch. You had to sort of get some C code provided by the vendor and translate it to Python. So that was also another part of it. But it was really good. And there are a few things that can come out of it, like JSON and XML parsers that we can add to MicroPython lib that I'll have to write. And I've been using Peter Hinch's font library to get the fonts working, which has worked really well. So I'll talk about it hopefully in more detail next week, next month, next meetup, and show some code, and I'll put the code up online. Also, I might talk about 1.25, which should hopefully be released by then, but that's another story. Anyway, that's all I wanted to say. If you have any questions, I can answer them.
You just answered the one I was going to ask about Peter Hinch's, if it was Peter Hinch's library, which, yeah, I've used that too. It's quite good.
Yep. Although it's quite slow when you want to render like 200 pixel high fonts. But that's okay.
Yeah, I've seen
RLE to the fonts.
No, I don't think it is.
Pretty block.
Okay. Yep. AJ's just commented that they're looking a little blocky. I'm wondering if RLE's implemented on the library.
You can, well, no, it's not. You can see the font is like, I mean, yeah, it's just literally black or white run. So RLE would go a long way to compress it, but you need to have it uncompressed to render it. We don't really have it on the fly decompressor. So it has to be stored.
Yep. The suggestion is to do RLE on the fly decompression.
Yes. That would be cool.
There's a lot of room for optimization here. Yeah. That's cool. Yep. Cool. I like it.
Damien, I did a ISS tracker on one of these little badger things, and it does start to push the limits of it because this is a bitmap of the world and it has to pull a load of things and find out, lots of bits and bobs. So I ended up moving a lot of the logic onto a server.
Right.
This is still rendered on the little Pico powered badge here, but there's a lot of server side stuff. And the weirdest challenge I found from that is actually what it shows at the minute. Google's geocoder is really good at telling you when you're over land where you are. When you're not over land, it basically just returns an error. So I had to use a completely separate service from GeoNames for, oh, it's errored. I'm probably over the ocean. Give me the name of the ocean that we're currently over, because obviously there's a lot of ocean and the ISS spends a lot of time doing that. So quite boring if it was just nothing to see here. But that's something that I did as a different project, also MicroPython. But what I wanted to do today